I had a student ask me about the difference between two distributions, the Poisson distribution and the exponential distribution. So that's what we're going to cover on today's video. I do realize that these two can be confusing because the problems sometimes look similar. In both cases, we see the rate at which events happen in a certain time frame, and we're asked to find probabilities about events which occur at a constant rate. With a Poisson distribution, though, we are looking at the number of events in a time interval. With an exponential distribution, we are looking at time between two consecutive events. The Poisson distribution is a discrete distribution, so your random variable x will take on non-negative integer values. So x can equal 0, 1, 2, and so on. The exponential distribution is continuous, so we are looking at an interval. We may be talking about a segment of time where x is units of time, like minutes or hours. But these problems can also be spatial problems. For example, cracks in a certain distance on the sidewalk. The Poisson distribution in this case is looking at the number of cracks in a certain distance. The exponential distribution would be looking at the space between those cracks. In this case, the cracks on the sidewalk are the events. This statement expresses how the two distributions are alike. If waiting times between events are independently exponentially distributed with parameter lambda, then the number of events in one unit of time has a Poisson distribution with parameter lambda. Lambda, in both cases, there is a rate. It's a rate per some unit of time or distance. Here we have the functions that allow us to find probabilities for these for random variables that are distributed with a Poisson distribution or with an exponential distribution. With a Poisson distribution, the probability mass function gives us the probability that x equals a specific value. The function is e to the negative lambda times lambda to the x over x factorial. With an exponential distribution, the cumulative density function gives us the probability that x is less than a specific number. We can also turn this around and look at the probability that x is more than a specific number. The probability for an exponential distribution, the probability that x is less than a specific number is 1 minus e to the negative lambda times x, where the probability that x is greater than a specific number is e to the negative lambda times x. Let's take a look at how this translates to doing real problems. Keep in mind that lambda, for both of these, we have to consider with the statements, take into consideration the statements given in the problems, because lambda depends on the unit of time required to answer the given question. So we're going to start with the same statement. On average, you complete 6 homework problems per hour, and then look at questions that could result. And here are 2 examples of questions that we could have after this type of statement. The one on the left, we would use the Poisson distribution, and the one on the right, we would use the exponential distribution. Let's look at Poisson first. A Poisson question is going to ask us about the number of events which happen in a unit of time. So the question is, what is the probability you complete less than 2 problems in 20 minutes? So in this case, 20 minutes is our unit of time, and we use this to find lambda. So since our expression was that on average you complete 6 homework problems per hour, in this case our unit of time is only 20 minutes, so we need lambda in terms of per 20 minutes, and we simplify 6 to 60, and that translates to 2 for 20 minutes. So lambda for this problem is 2. And we're looking for the probability that we complete less than 2 problems in 20 minutes. So we need to sum the probabilities that x equals anything less than 2. So the probability that x is less than 2 is equal to the probability that x equals 0 plus the probability that x equals 1. Here we just use the function from above and substitute our values for x here, here, and here, 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 and here, and then lambda. Our answer tells us that there's about a 40% chance that you complete less than 2 problems in 20 minutes, given that you average 6 problems per hour. Now let's take a look at an example using an exponential distribution. So what is the probability that you complete a homework problem between 5 and 8 minutes? And what this means is to solve this problem, we need to first find lambda. So lambda is now 6 over 60 because our unit of time is now minutes. We could solve 6 problems in 60 minutes, so lambda for this problem is 0.1 per minute. And notice the difference here. The reason lambda is different from the lambda we found in the other problem is that our unit of time has changed. The unit of time here was 20 minutes. The unit of time here is simply minutes. So to solve this problem, we want to find the probability that 5 is less than 8, or less than x is less than 8. And to do this, we just want to find the probability that x is less than 8 minus the probability that x is less than 5. And let's take a closer look at that. When we solve this part, we're finding the probability that x falls somewhere here. When we solve this part, we're finding the probability that x falls somewhere here. When we subtract this segment, we're left with only this segment, which is what we're interested in. Here again, we're substituting into our cumulative density function, lambda, and our values of x, simplifying, and we get that, and we find ultimately that the probability that we complete a homework problem in more than 5 but less than 8 minutes is about 16%. Hope that helps.